Welcome everybody to this Windows demonstration of how to use Docker. So the first thing that we want to do is to make sure that our Docker engine is actually running. So once you've installed Docker, I think it'll by default create a shortcut to your desktop. So you can just double click on that. If there isn't a shortcut on your desktop, you'll just go down here to your applications, program files and type Docker and it'll come up with it. So we're just firing up Docker desktop now, and it'll sometimes take a minute or so to get up and running. So while that's doing its thing, we're going to be interacting with Docker using the Windows PowerShell, which you may or may not have used before. So if we go down here and type PowerShell, the app comes up, just click on it there. Sometimes it takes a little second or two to actually fire up. I find the text a little small, so if we right click up on the little blue icon up here, go into properties, font, we can actually make the text a little bit larger, and it's easier to see. It's pretty better for the recording anyway. So let's do that. And you can see in the background, Docker engine was starting. We just got a little message down there about it. Let's just see, yeah, Docker engine starting up. So just give that a few seconds to start up. So it's important that Docker is actually running on your computer before we actually start interacting with it using the PowerShell. So we're going to be using the PowerShell. We're going to be using Unix type commands to interact with our computer using the PowerShell. The first thing we're going to do is actually navigate to where our various documents are. So if we type ls, that'll list all the files where we are currently. Ultimately, I'm going to want to go into the documents directory. So if I just type cd, which stands for change directory, and then start typing documents, and then press tab to autocomplete, it'll take me to the documents directory. And if I type ls again, it'll list all the files that are in that directory. So we can kind of see all the files there. Let's just make this a little smaller if I can. Oh, there you go. Okay. Whoopsie, there you go. Okay, so Docker engine looks as if it's started in the background. So to check that we've got Docker up and running, go back to our PowerShell and type docker -- version, and we see there we're running version 20.10.6. We're running Docker. To check that our installation is working okay, we're going to run start up a Docker container. We're going to start up a small Docker container called Hello World, which we'll just check to make sure that things are working okay on our computer. You won't already have this container on your machine, so when we type docker run Hello World, it'll actually download it from Docker Hub because it'll recognize that we don't have it on our machine. So if we type docker run Hello World, just give it a few seconds, so it runs the Hello World Docker image. Hello from Docker. This message shows that your installation appears to be working correctly. So that's an image that we've now downloaded onto our computers. I use Docker quite regularly, so I've got lots of different Docker images on my machine. If we type Docker images, we'll see those that are listed in my machine. So I've got about 5 there. Some are actually quite big in size, almost 5 gigabytes, almost 4 gigabytes, almost 4 gigabytes. The first time that you use Docker, if you've just done docker run Hello World, you'll just have the Hello World Docker image, which is titchy tiny at only 13.3 kilobytes. So the Hello World example is just a very trivial example to show us that Docker is running okay on our computers. What we're going to do now is run a Docker container that is an image comprised of RStudio and a bunch of tidyverse packages. So this can take sometimes 10 to 20 minutes to download from Docker Hub the first time that you run it. Once it's on your machine, it won't download it again. So we can type docker run. We're going to add a couple of flags. The RM flag will basically shut down the Docker container when we quit it. We're going to use the --p flag, which basically says map the Docker container port to port 8787 so that we can interact with the Docker container using our web browser. I'm going to set an environment variable. I'm going to set the password for our RStudio running in our Docker container, simply as the word password, and we're going to fire up the Rockerverse. So the Rockerverse is a pre-built Docker image containing our RStudio and these various tidyverse packages. So if I just press return, it should start pretty quickly on my machine because I think I downloaded this Docker image relatively recently. So the Docker container is running. Of course, nothing's happened on our screen because we haven't set up things to interact with it yet. So we interact with our Docker container that's running via our web browser. So in this case, we're using our web browser not to access the internet. There's the great University of Manchester website opening up very helpfully. We're going to use our web browser to interact with the Docker container running on our local computer. So up in the web address, we're going to type localhost 8787, and that will then connect to the Docker container that's running on our machine. So the username for this version of RStudio is just RStudio, and the password is what we said earlier, which is password in lowercase. And if we sign in our web browser, what we're able to do is see the Docker container that's running on our computer. So it's our version 4.1.1, RStudio. Click on packages, kind of see a whole bunch of packages, including down here. If I can scroll down, where's it gone? Tidyverse version 1.3.1. So this is our RStudio running in our Docker container. It's not the version of our RStudio we've actually got on our laptop. So it's a little bit, if you remember when we looked at Binder in one of the previous sessions, it's a little bit like that. One of the problems with Binder is that you can use Binder to fire up a Docker image to create a Docker container on your machine, but what you can't do is anything other than run the script that's in the Docker container. So you can't make changes to it and save those changes. You can't access data that's on your own machine. You can't export or anything like that. So it's kind of a bit limited. What we can do with Docker itself, and this is what we can't do with Binder, is actually set up a Docker container so that it can interact with a directory on our own computer. So we're just going to shut down this one container that's running by pressing, if I can remember right, it's either Control X, Control C. There you go, Control C will shut down that container. So now what we're going to do is run that Docker container again, but we're going to run it so that it's connected to a working directory that we're already in. So let's just have a look at what I've got on my computer. So I've got the UFO directory. Let's go to that. You'll recognize this from, I think, week 1 or week 2. So I've got a whole bunch of files in there. I'm just going to delete one of them. I'm going to delete using the rm command. I'm going to delete the file called test.r because we're actually going to recreate it anyway. Okay, so we've got a bunch of files in our UFO directory, and what I want to do is fire up the Docker container, but have it connected to this directory on my local computer so we can use what's in the Docker container to kind of read and write locally as well. So we're going to Docker run. So same flags as before. One new one is going to be, we're going to set the volume that it can interact with. So -v sets the volume on our local machine. On Windows, this is slightly different from Mac and Linux. Type pwd in curly brackets. So that's the path of the working directory, the directory that we're currently in. And we're going to map that on to within the Docker container home RStudio. Let's spell it correctly though. And we're going to set our environment variable again. Password, and we're going to run the Rockerverse image rather. So let's just press return. Just give it a wee sec. Yeah, we want Docker to be able to access a file on our local computer. Ooh, that port is already allocated because I guess our previous Docker image didn't shut down properly. So let's have a look. Do we have anything? Yeah, we do have something running. So we need to shut down that Docker image. Okay. So I am going to pause this video and do like a very quick bit of Googling. And then I will show you how you shut down a container that's already running. Okay, so we want to use the Docker command docker stop, and then the container ID. So I'm going to type this F48FDE1204BC, and that should stop that Docker container, which was kind of occupying the port that we want to use. Okay, so it looks as if it's succeeded. So you can go back, run the docker run command. You can use the up and down arrows to cycle through previous commands. So let's restart our container. Yep, that's looking good this time. Go into localhost, type RStudio as our username, password as our password. And what we have when that's fine, is fires up. Just close that. What we have when it fires up is the Rockerverse running, but this time we can now see the files that we have on our computer locally. So let's go up here. Let's create a new file. Let's just have something like, print this is a test. That's our new file, terribly exciting. Let's save it. I'm going to save it as test.r. So let's save that. Let's quit this container that's running. And let's now look at the files we've got locally. And you see we've now got a file called test.r, which I just created. So we're able to fire up the container and now interact with our local working directory. So that's a super useful way of interacting with stuff on your laptop using a Docker container. So we're kind of accessing things from the Docker container that are local. So let's go back to the container that's up and running. Just need to log in again. I probably shouldn't have closed that down. So you see we have various packages installed. We don't have the Gapminder package, which you might remember us using a fair bit in the R unit. So let's install the Gapminder package. So we've got our Rockerverse container. We are installing Gapminder in it. So in a sense, we're kind of updating the container that's running. And what we want to do now is resave this new expanded container that contains the Rockerverse plus Gapminder. So we're going to open up another PowerShell window. Just give it a wee second or so. It tends to run a script or two when it's starting up. There we go, finally. I was getting slightly worried there. So let's just see what Docker containers are actually running. So we've got this Docker container running, which is the Rockerverse, but we've also added Gapminder to it. So let's actually create a new Docker image from the one that's running. So we'll use docker commit. We're going to add a message using the -m flag. That's going to be verse plus Gapminder. So it's going to be an expanded version of the image, and it's a container ID 779053F35, and we're going to call it verse underscore gapminder. Okay, so now if we type Docker images, you'll see that we've got a new Docker image that we've created, which is the Rockerverse plus the Gapminder image. So let's just close down the container that's running. Let's see what container is running. So Docker stop, and then it was a container 779035F35. Stop that container. Just take a wee minute or so to stop. Let's just go back to the other PowerShell window because that's actually in a folder that we're maybe wanting to use. So now let's start our new Docker container, connect it to our local directory, and when we've started up, let's see if it has Gapminder already installed. So we're just going to map our current working directory onto home, RStudio. We'll set the environment variable again, password, equal to password. And we're now going to fire up a container based on our verse Gapminder Docker image. Type it there, okay. So let's start in the container. Let's hop on over to Chrome. I really must change this default homepage. And now, hopefully you'll see, I've got it running with the test.r thing on boom. If we go down to packages, we see now that we have got Gapminder already installed because we updated our Docker image that contained this extra package. We used the Docker commit command to do that. So that's a very brief introduction to how you get a Docker image up and running as a container, how you connect the Docker container so that it's able to read and write to a directory on your local computer, and then how you, in a sense, you can save that entire Docker image if you're adding functionality to it through additional R packages or whatever. And these Docker images are incredibly useful. You can imagine working in an organization where every data scientist, every researcher is required to use the same configuration of R or Python with the same package versions. What they'll do is basically fire up the official Docker, official Docker container that their organization uses, and then we'll use that to interact with data files, with scripts, everything else that they might have saved locally on their own laptops. So what we're going to do in the next video is I'm going to show you how you write a Docker file to create your own Docker images, which will contain a particular version of R, a particular version of RStudio, data, script, etc. So that then you can share that Docker image with your collaborators, with your supervisor if you're working on a big research project, or even just with your future selves. There have been many times in the past where I've tried to rerun analyses that I carried out several years ago. I've not been able to get the same results because of changes maybe in R or in one of the packages that I'm using. What would have been super helpful if I'd known at the time was if I'd built my analysis in a Docker container several years ago, I'd actually be able to fire up that Docker container now and basically have the computational environment on my machine now exactly the same as it was when I did the analysis originally. So building these Docker images and firing up these containers isn't just useful in terms of collaborating with others, it's also useful in terms of your future selves being able to revisit analyses, etc. that you did at a particular point in time. So anyway, in the next video, we'll look into how we actually write our own Docker files to create our own Docker images.